Welcome to the lecture series on soft computing in computer science. In our previous lecture, we could see the major steps of genetic algorithm, and I concluded with the idea of why GA has its name. To begin with today's presentation, again I am revisiting the slide why GA has its name. If you could see that there are three partitions. One is mathematical name, corresponding example, and the genetic name. In general, everyone has to follow the genetic name while we are discussing about the genetic algorithm, like gene, chromosome, population size, and the genetic operations as well as generation and all. But to begin with, as a computer science student, you should understand this genetic algorithm as an algorithm consists of 6 steps as illustrated in the last lecture. While solving any optimization algorithm using genetic algorithm, the problem statement given consists of 2 components. One is the component which has the minimize or maximize with respect to the optimization criterion, and another one is a set of decision variables that are involved to solve this optimization problem. So those things are called by the name. In a mathematical approach or in a mathematical way, they are called by the name objective function or fitness function. But genetically they are called by the name an environment. So what it means is, an environment is given in a mathematical equation, and you should find a suitable value for the solution variable so that we reaches the desired goal. When this kind of objective function is given, that this environment is given, you should identify the set of solution variables like x1 and x2. Genetically they are called by the name gene. That means genetic algorithm context we will call by the name gene. If x1 and x2 are put together, then it is called as chromosome, whereas in the mathematical we are calling by the name set of solution variables. The set of possible values for all the solution variables are called by the name population in the genetic algorithm context, whereas it is in general called by the name number of possible values for the solution variable. Likewise, when you recall the 4 major operations that has been executed in the flow of genetic algorithm, they are popularly called by the name elitism, selection, crossover, and mutation. Those are all the names in the genetic algorithm context. But ideally in mathematical way they may be called them as, or in an algorithmic way they may be called them as certain operations, keeping the idea of bringing some better individuals in every iterations. So likewise they have the name as elitism, selection, crossover, and mutation. Finally, since it is an algorithmic idea of solving the optimization problem, it has to be executed in an iterative manner. So those iteration is called by the name generation here. So this is why the GA has its name. Now let me check why this GA has this idea and where this idea has got inspiration from. Let us recall Darwin's evolutionary theory. Darwin's evolutionary theory is the fundamental theory for organisms' evolutions in the world and their survivability. What Darwin says that is, the survivability of any living creature is not the result of divine intervention but due to desire to seek perfection. We can rewrite this statement according to the genetic algorithm. That means the survivability of any possible value that is randomly generated is not the result of its identity or its creation, but its survivability is completely depends on the suitable or the maximum or the optimal or the minimum. That means the optimum value obtained for a particular objective function or an environment. That is the idea here. If it is giving best value for the objective function, then it will be get survived year after year, that means generation after generation, that means iteration after iteration. Otherwise it will go off through what kind of operation that is mentioned in the previous slide, that is selection operation. In general, what Darwin has observed is the primary goal of any creature is to select, mate and have as many as offspring as possible. The same principle is coined here with respect to genetic operations like elitism, selection, crossover and mutation. So those operations are repeatedly carried out in order to find a suitable or in order to find a new variable value, so that that variable value will bring a new value or new optimal value for the objective function. So it means that according to Darwin's theory, all living creatures are constantly changing and evolving into what they are now. That means whatever the possible values or whatever the possible values that we have randomly generated, they should be evolved. That means they should be changed, but within this constraint, range constraint that have been provided in the problem statement by means of the operation that we have been applying iteratively over many iterations. They keep on changing. The survivability depends on the one which gives the maximum value, right. So look at this picture. This animal is having a long neck. So imagine when the world was created, there are trees or there are some grasses which are in the average height. Suddenly, due to some natural calamities, if the tree height is growing very long, so the animal which is having the normal leg will able to survive, will able to grasp, will able to eat the grass, or we will able to eat the leaves in the plant as much as possible. Suppose due to some natural calamities or due to some natural disaster, if the tree has grown rot, so the animals with a smaller neck can't able to feed for them, because they have to seek or they have to get the leaves or other things into a perfect manner. So accordingly, it is observed that there might be some genetical change in the organisms. According to the genetical change, there might be some scenario, the leg may be grown very longer in order to, so that means the survivability. Likewise, take the scenario of the birds. The bird which is in the original shape, the mouth of the bird is very long, but accordingly over the period of iteration, the mouth is become very, so that means it's see, the primary goal of any living creature is based on the food behavior, based on the mating behavior. So accordingly, the evolution process is going on. So this is the basic principle of Darwin's evolutionary theory, and this Darwin's evolutionary theory has been inspired for solving the optimization problem, that is the survival of the fittest. So let us once again illustrate this idea of genetic algorithm for a mathematical problem through a simple case study. If you look at the problem statement, so mathematical context, I can say that this is a problem statement. In a biological context, that is in the genetic algorithm context, I could say that this is an environment. So what is the environment given? The environment given is f of x comma y equal to x square plus y minus 11 whole square plus x plus y square minus 7 the whole square. So this is the environment given. What is the condition given? The variable x and y should be within a particular limit. For x it is 2 to 5 and for y it is 6 to 9. So what is this problem statement is conveying? We should find the value for x and y that should be within the given range. For x it should be within 2 to 5 and for y it should be within 6 to 9. That value, after substituting the suitable value of x and y, the value of f of x should be a minimum value. That is, the objective is to find a minimum value for f of xy by substituting the suitable value for x and y. So this is the situation given for solving the optimization problem through genetic algorithm. So how we solve this problem? There are 6 steps as I illustrated in the previous lecture. The first step being the representation of the solution variable. Second step is random initialization of set of possible values. Third step is evaluation of each variable value, and fourth step is finding the best possible value. Fifth step is applying the generical operations in order to bring out new set of possible values, and the last step is iteratively conducting the step 3, step 4 and step 5. So you have to apply all these steps in a systematic and organized manner. Accordingly and eventually at one particular point of time you will get a very good as well as an optimal value for the problem. So I tabulated the results in this slide. So where we have to start? We have to start with the initial population. Let me take some pointer. Yeah. So we have to start with the initial population. That means the step 1 is representation of solution variable. If you could see that the x value is 4.797 and 6. So what is the representation strategy followed here? The representation strategy followed here is real number representation for the solution variable x and y. I think you remember why this x and y is called solution variable, because the value of this variable only gives the solution for the problem. So it might also called by the name solution variable, or in general it is called by the name decision variable. Now you could see that there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 different possible values are there. So what is capital N? You could, if you could remember my previous lecture, you could say what is capital N? Number of set of possible values for the solution variable. So how many number of possible values we have taken? 10 possible values we have taken. So this is going to be the initial population for the variable x and y. If you could see that the value of x should be within the given range 2 to 5, and this variable should be within the range 6 to 10, because the problem statement given to us is like that. What is the second step? What is the next step? So what are the steps have been over? The step 1 representation strategy is over, that is representing the variable using a real number. Step 2, random initialization of the set of possible values, right? So 2 steps are over. So what is the third step? Evaluation of the fitness value. If it is a binary number representation, students please remember that you should apply a linear mapping rule to convert the binary value into the real value. If it is a real number representation, though there is no need of that overhead of doing that activity, then straight away you go for evaluation. So what is that? You have to substitute 4.7 and 6.98 this value into the given function. So what is the function given? The function given is f of x comma y equal to x square plus y minus 11 whole square plus x plus y whole square minus 7 the whole square. So you have to substitute x, you have to substitute the x value here and y value here. What is the value we got? So if you could see the thing 4.97, so 4.7987, 6.9861, this value you have to substitute there and you will get the fx xy value, right. So like this you have to find it for all the 10 possible values. So that is the fourth step. What is the fifth step? Applying the operations, right. So before that you should say what is the best possible value. Since it is a minimization function, so the best possible value here it is displayed in red in color. Sometimes the minimization problem has to be converted into a maximization problem by taking the reciprocal of that. So here this case the fitness function value that is represented is nothing but the reciprocal of the given objective function. So what is the maximum value? So minimization problem will be now converted into a maximization problem. So what is the maximum value obtained at this particular step? 0.6047. 0.6047. What is the minimum value? That is not, we are not bothering about it, because we converted into the minimization problem into a maximization problem. So this is the minimum possible value. But why we have to record this minimum possible value as is, in order to prove that, gradually all set of possible values will try to give the increase or improvement in the minimum values as well as the maximum values. This on an average, all set of possible values are keep on updating themselves in order to desire or in order to seek the perfection according to the environment, to prove the principle of survival of the fittest. Let me come to the first operation. This is step 5. So what are the operations? Elitism is one operation, right, and selection is second operation, crossover is third operation, and mutation is the fourth operation. So what is elitism, or what is first operation? Process of keeping the best two individual in a separate locations or separately, because that may be needed for future purpose, that may be needed to mingle with the new set of possible values that is created through operations. What is the second operation? That is selection. There are a lot of selection algorithms are available. Let me that I will introduce in the subsequent presentations, subsequent slides. But what is selection, or what is the goal of the selection? You have to identify the least set of value, and you have to identify the best set of value, and you have to give more priority or more number of representation you should give for the best possible value. That means the best possible value will sometimes begin to override or begin to dominate or begin to suppress the lower valued variable. So here if you could see that this will give you 0.5207. So that value is a 2.3 and 6. So randomly it will be replaced with the best possible value. Likewise, the best possible values are replaced and it is given in the different color, green color, for all the cases. See, in the beginning stage it is 4.6174 and 7.5296, and it is giving 3.306, but now it has been replaced with this new set of possible values. How this new set of possible values in selection process is coming out? The one which is giving the best value. What is the best value combination? If you choose x 4.687 and y 6.253, 293, that value is getting repeated here. So that is, more number of representation will be given for the best value, and lesser or even zero representation is given for the worst value with respect to the environment given, that with respect to the objective function given through the operation selection. Followed by selection operation, there is the very popular operation, that is crossover operation. So in crossover operation, two possible values have been randomly taken and their values are swapped. Remember students, while doing the crossover operation, you should not violate the border constraint, that means a range constraint. So within that range, you should ensure that that crossover operation has to be carried out. Say for example, if I want to cross over these two value, x value with the y value, this value comes here and this value goes here. Let us take an example. Whether this scenario is correct? Absolutely this scenario is wrong. Why? Because the value x should be within the range 2 to 5 and the value y should be within the range 6 to 9. So 1 to 5 the variable value should not be replaced with the 6 to 9, and 6 to 9 variable value should not be replaced. But how that crossover operation has to be carried out? There are plenty of crossover operations are available that will take care of the border violation as well as the constraint, and whenever you are trying to produce a new possible value through this crossover operation, it always ensure that you should be within the limit. Then comes the other operation, that is the final operation of the genetic algorithm, that is mutation operation. In mutation operation, what is actually carried out is a single value has been randomly chosen and its value has been replaced, or some kind of calculations are also being involved in order to produce a new value. As biology says that what is mutation? It is a sudden change in the living organism. Likewise, there is a sudden change of the value that must be carried, that must be brought it into the operation, either by changing the value to a nearest value or some other new value by means of certain operations that is predefined. There are a lot of mutation operations are also available, right. So now if you look at the operation, see, this is a new set of possible value. Let me take some eraser and yeah, see, if you could see that, so this is the original population, this is our original population. So these are all our original population, that is random initialized population, right, and these are all our new population, that is this is newly created population or updated population, newly created updated population. So how this updated population comes in, these 4 operations are responsible for bringing the R to U. Now if you evaluate objective function value for this new set of population, you got a new value, and if you do the step 2, 3, 4 repeatedly, eventually you find that there is an improvement in the best possible value. See, the best possible value in the initial stage is 0.6047. So immediately in the first iteration itself, you could observe that there is a change in the best possible value, and it is 0.8439. So likewise, you should understand the operations clearly in an iterative way. At one point of iteration, you would got the best possible value. Let me discuss about the genetic algorithm and its different variants. So where you have to start? In order to understand the genetic algorithm, you have to start the problem representation strategy and how to initialize the population and how to evaluate the objective function. With respect to problem representation, we have variety of genetic algorithms like binary GA if you use binary numbers, integer GA if you use integer numbers, real coded GA if you use real number, that is floating point numbers. Accordingly, you have variety of GAs. With respect to operations also, that means genetic operations also, you may have lot of genetic algorithms. Simple GA, that means simple operations like LDSM, simple crossover, that means a single point crossover, and mutation, that is a single bitwise mutation, and you will come across as normal tournament selection. So like that, if you use a simple operation in order to bring up the new values, then it is a simple GA. Some advanced operators, that means you may call it by the name improved GA or enhanced GA, or you can bring operators from some other algorithms. If you bring operators from some other algorithms, you may treat that algorithm as a hybrid GA. So like that and all you can carry out. So in the literature, if you go through it, you can find a lot of genetic operations, and all these genetic operation objective is to find a new possible value for the existing value or for the randomly generated value. So this is for your understanding how the GA has got its many names, either by means of the representation strategy or by means of the operations involved. So what are the major operations? LDSM, selection, crossover and mutation. This particular slide will show you the some elite kind of crossover operation, mutation that are widely used in many of the research papers for their research problems. So those I have listed here. Next, come to the selection process. So selection process, if you want to introduce into your genetic algorithm, you should remember the objective. So the exact survival of the fittest principle has been properly implemented in this particular roulette wheel selection task. So selection task in general. So roulette wheel selection task is a kind of selection task. Likewise, we have tournament selection, rank selection. There are many selection strategies are there. In roulette wheel selection, the circumferences of the wheel, if you could see that what is the circumference of the wheel, this is the circumferences of the wheel are marked with the fitness proportions value. So all the partitions are treated as the proportionate of the fitness value. So first you calculate the fitness value has been compartmentalized, that is divided into as many as partitions as they have in the whole 100% of the population individuals. The wheel is rotated, that might be n times or that may be 2 times or 3 times, and there is a pointer head that points the value. So what is the probability of getting the value in the subsequent iteration? One that has the maximum space will have the possibility of getting always selected. That means the lower value will get suppressed by the bigger value. That means what I am trying to convey here is the value which is having maximum fitness value is treated as the best value, that will have more number of representation in the subsequent generation by eliminating or by overwriting the first value. So this is again the analogy of the Darwin's evolutionary theory, by that means survival of the fittest. That means the individual, two individual which is having only smaller percentage of producing the fitness value are no longer needed in the subsequent generation, and their survivability is 0 in the subsequent generation. But the variable which is very large enough will have the largest space in the subsequent iteration. Next, tournament selection. In order to implement this tournament selection, first you should initialize the tournament size, then you have to prepare the schedule of tournaments. So here the tournaments schedule is 2 tournaments. So one tournament player will get the 4 as their winning point, another one is the 8 as the winning point. Now you should compare the 4 and 8. Which one is greater? 8 is greater. So accordingly you should display the winner. That means you have to randomly select 2 individuals from the set of individuals. So here in this case this is one individual, individual number 1, this is another case individual number 2. Now the every gene value, this is every gene value has been compared with the other gene value. So the one which is having the greater value has been chosen as the final winner. So accordingly you have to do it for all the cases. So this is another way of doing the selection, and it is called tournament selection. If you could see that, so these value accordingly you have to pick the individuals and you have to go in for the next operations. The next operation is crossover operation. So 2-point crossover is a very simple understandable crossover for understanding the genetic algorithm task. So in 2-point crossover what you have to do is you have to choose a point. That point is called as crossover point. There are 2 crossover points are needed or required in order to do this operation. Here in this case you have 2 crossover point, one is crossover point 1 which starts in the position 4 and another one is crossover point 2 which starts at the position 14. Now if we want to do crossover operation, see I have chosen 2 individuals randomly, let me name that individual as parent 1 and as parent 2, and if these 2 individuals are going to do apply for the crossover operations, then you have to select the crossover point like this, and then you have to do the crossover operation. So up to this the white matter is here in the child, then this grey matter come over to the parent 1, that means child 1, then this white matter will be coming down to the next stage. So likewise you are producing the new offspring during the crossover operations, and it is expected that this new offspring that is created by this operation is ideally and producing the better possible values in the next iterations. Next, arithmetic crossover. This crossover is a popular crossover for doing the real number presentation. And come to the bitwise mutation. This bitwise mutation is very popular for a binary number representation, for which you have to create a mask, and that mask value will be utilized for flipping the 0 value to 1 and 1 value to 0. So wherever 0 values are there, it has been randomly selected and its values are converted into 1. Uniform mutation. This is a real number mutation. So you have to generate a real number within the allowable range, for which there is a formula. So you have to select the maximum possible value as well as the minimum possible value, and you have to substitute, and you will got a new number, and the new number within the range, and that will be uniformly distributed over the entire population size. So this is the uniform mutation. So if you could see the convergence process, so if you could see that, so initially the algorithm is producing the fitness value here. So over the period there is a jump and there is a small stagnation, and iteration by iteration the fitness values are increased, and at what particular point where you have to stop the GA process. If there is no improvement over the particular period of iteration, then you have to convert the process, and you have to display the result that produces the x value and x2 value. So at every point of time you have to display the best value as well as the average value. At the final point you have to display the x and y value and the final convergence value that is produced by the GA. So with this we close this lecture on understanding the genetic algorithm process through a case study. Then we will discuss about the genetic algorithms applications and various algorithm that follows the style of the genetic algorithm. Thank you.